today's video is your Quiz 6.3 review. Question number 2 that you're going to see on today's quiz, as well as question number 1, is going to ask you to solve for x. Remember, when you have two rational expressions set equal to each other, you're just going to go ahead and cross multiply to solve. Be careful for both of these because, as I notice with the blue one, there's a minus in the bottom, a subtraction. So I'm going to have to go ahead and say -4 times x minus 7. Then I can set it equal to, and then I noticed that again when I did the pink one, -10 times x minus 4. The reason I have to make sure that I have my parentheses is because I have to make sure that I distribute. So I'm going to go ahead and say that that's -4x. I'm going to go ahead and say that that is negative and negative makes a positive, 28. -10x. And then once again, negative and negative is going to make a positive. And we've got 40. All right, we've got an x on both sides, so let's go ahead and move one. In this case, I would go ahead and bring the 10 over because -10 is smaller than -4, but it's not wrong to go ahead and move the -4. I chose this because it's going to give me a positive 6x. There we go. And now I just have my two-step equation to solve. Okay, so I'm just going to go ahead and finish solving that. It looks to me like Alex is going to give me a whole number answer on this one because there, as you can see right here, there is no toolbar for me to possibly get a fraction or anything like that. So I'm going to go ahead and guess that my answer will be a whole number because Alex will set me up with the tools if it is not. So I got 2 for an answer. All right, let's take a look at the next question. I debated on whether I should show you this, but I'm going to go ahead and do so anyways for 2 reasons. The first reason is as I look at this, I notice that maybe we might forget that it is the same as the last question. We just got to put the -6 over 1 so that we can cross multiply. I would go ahead and, of course, set up the parentheses once again right here because of that subtraction x minus 8 in the denominator. And then I am going to have to, when I do this one, I am going to have to grab this negative and stick it up here with the 3 so that I have -3 times +1. Okay. It is looking like, based on my toolbars here, that I do have the possibility of a fraction answer. I do have the possibility of multiple answers. I do have the possibility of no solution. And of course, I do have the possibility here. I would say your answer is probably going to be one of these two. For this one, more leaning towards, of course, the fraction. Let's go ahead and distribute. -6 times -8 is +48. And of course, -3 times 1 is -3. I just have a two-step equation here, so I'm going to go ahead and solve like I normally would. They're both negative, so I can just simply go 48, 49, 50, 51. And then, of course, I do have to go ahead and divide to get rid of the -6. Now, I don't think 51 goes into 6. I don't think there's a number that goes into both of them. I'm going to go ahead and check 51 for 3. Oh, look at that. 51 is divisible by 3. So I'm going to go ahead and divide this by 3 and divide this by 3. Let's see, 51 divided by 3 would give me 1 with 2117 over 2. And it is going to be a negative divided by a negative, which is going to go ahead and be a positive. So I'm going to go ahead and say my answer is 17 over 2. And I would just leave it right like that because Alex is not asking me to round. All right, then you are going to see a question like this. For this question, remember that you're going to simply look at your denominators. So you want to look specifically at the two that have just an x. Now, those two should be the factors of this one with the x squared, the polynomial, the trinomial. So what I'm going to look for is, of course, x squared is going to be x times x. I need to factor it. And then I'm going to say 30. Is 30 6 times 5? Well, yes, it is. So I'm going to go ahead and factor using 6 and 5. And of course, the reason that I want to do this is because then I can easily solve this problem. Now, the middle here is negative 11x, and I believe that I can make 6 and 5 be 11, negative 11 if they are both negative. Look at that. I've gone ahead and I factored. I have gone ahead and I factored. This one is the pink. This one is the blue. That means that this is going to be my LCD. Now remember, what you're going to do is you're going to multiply this side times your LCD, and you're going to multiply this side times your LCD. Okay, we're going to go ahead and we're going to distribute it. So let's go ahead and see what that looks like. It's just a bunch of copying. Now, remember right here, I'm going to go ahead and put um, that first pink denominator into a fraction because they will cancel, leaving me simply with 4 times x minus 5. Could I have kept it the other direction? Sure, I could have, but I wanted to see it in a normal distributing pattern. So it's better to put the 4 first. I got to pay attention to the symbol in between um, my original rational equations because and I've done this myself. I've gone ahead and made a mistake, especially when it is a negative, when we are subtracting, when it is a minus. Same thing here. I'm going to put that blue one in a parentheses. Now, remember, we did talk in class about thinking about this as being over 1. So we could do that as well. But the one's just going to simply disappear because even if I do multiply, it just disappears, right? I would put this over 1 and I really don't have to, right? Okay, so this one is going to cancel that one, leaving me with still the plus and the x from the original problem times the x minus 6. All right, now I've got my equal sign right here, and I'm going to go ahead and do that one more time on the other side. Now, one little change that I'm going to do to the original problem in the green highlighting is I'm going to take it and write it in its factored form. I'm not going to put it in its given polynomial. The reason for that, as you're going to see in just a moment, is that this way it's easier for me to see that they're going to factor, or that they're going to cancel. And of course, even if I keep the bottom, I have negative 5 on the top, I have divided by 1 in the bottom. So notice I do have all these divided by 1s, so since they're all there, they can go invisible just like that. Okay, now I'm at the point in the problem where I'm simply going to distribute the 4, and I'm going to distribute my positive x. Here we go. Sorry about that. Okay, after I've done that, I'm going to look over here on the longer side. Okay, and I'm going to see if I can combine anything. I'm pretty sure that I can go ahead and I can combine the 4x and the minus 6x. So I'm pretty sure that I can go ahead and write this in this form. Now, what you see that I have gone ahead and done is I've written it in standard form. The reason for this, I want to have the x squared term first, then I want to have the bx term, and then I want to have the c term, right? Because I want it to look in standard form, which looks like this. And the reason for that is because my next step is going to be to factor. Now, you want to make sure that you're paying attention to where your x squared is. Mine is over here on the left side, so I want to take this -5 and I want to move it over here. I'm going to go ahead and do that by adding, and of course, its common term is the -20, the -20. So that -20 plus 5 is going to become -15. And now I'm going to go ahead and I'm going to factor one last time. I'm going to go ahead and say that x squared is x times x. And 15, it is negative, so I do have a positive and a negative. I'm going to go ahead and use 3 times 5. It's the only one that I can think of right off the top of my head. So I'm going to go ahead and use it. And I think I can make 3 and 5 be 2. I can make them be -2 if the 5 is negative, right? So I can go ahead and factor this into x minus 3, sorry, plus 3, and x minus 5 is equal to 0. Now I simply use the zero product property to set each one of my factors, my parentheses, equal to 0, and I solve. Remember, the little trick is that you're just doing the opposite of the sign. So 0 minus the 3 is going to be -3. And then for this one, if you remember the little trick, you don't have to show me the addition or the subtraction, but of course for this one, we just simply added 5 to cancel it out. All right, so I have the two answers. However, I can have extraneous solutions. Remember, not both of them have to be answers. So I need to go back up to my original and I need to look at my two denominators. So let's go ahead and look at my denominators. Now, I did have three denominators. I kind of lied there. But the only two that I have to look at are the pink and the blue. Why only the pink and the blue? Because the green factors into the pink and the blue. So I don't have to look at the green one because it's the same. So let's go ahead and take a look at the pink one. These are my extraneous solutions. These are the ones that cannot be the answer. So my first answer that I cannot have is 6, and this comes from my pink one. Now let's go ahead and look at the blue one. I'm going to stick it over here on the right side of the screen. Same thing. I cannot have +5 as an answer. Okay, these are my two non-answers. So let's go down there. We're looking for no 6, no 5. -3, that's an answer, but +5 cannot be an answer. That one is extraneous, unfortunately. So the only answer I would put into Alex is -3. Now, could you get more than one answer? Yes. Then you would go ahead and click this tool, or you could simply use your comma and put your other answer. Could you have two extraneous solutions? Yes, you could, and then you would go ahead and click no solution. All right, the last portion of the quiz is going to be graphing. There's this question right here, which is pretty straightforward. You're going to be answering 3 questions based off of the graph that is given to you. Now, I specifically chose this one because it had 2 vertical isotopes and 1 horizontal isotope. So the first thing it's going to ask you for your x and y intercepts. Remember, this is just where the graph is touching the x-axis, where it is touching the y-axis. So it looks like my graph is touching the x-axis right here at 2. So I would just go ahead and click that button. And it looks like it's touching my y-axis right here at -2. So I would go ahead and click that button. Now, just like I said, my vertical isotopes are going to be x equals, and it's going to be these two right here, -2 and +3. So I'm going to put x is equal to -2, then I'm going to click the and button, x is equal to 3. And I just want to slide over and show this to you. I'm going to be clicking this one right here. Could you type out the word and? Maybe, but I would just go ahead and click that. Type in this, click that button, type in that. All right, let's look at our horizontal one. This one's going to be y equals, and it looks like it's right there on the x-axis, so that, of course, is 0. Your domain and your range, remember, go off of your asymptote numbers. So remember, your domain is x and your range is y. And so you're simply going to use, yep, you guessed it, x and y. You can follow your notes for this one. Since I have the 2, I'm going to put the smaller for x. Since I have two numbers, -2 and 3, -2 comes first, then I'm going to use the union. Then I'm going to go between the two numbers where the isotopes are, union, and then I'm going to use the higher of the two numbers and positive infinity. So that one's going to take me a little bit longer because I do have the 2, but the union symbol is right here. And of course, I can use the parentheses given to me in the toolbar or in my keypad. The range is going to be a little bit easier because it is just 1. I think the answer to that is actually in your notes for one of the examples in lesson 6.5. All right, then you're going to go ahead and have this question. Remember, for this question, you can go ahead and identify your A, which is the top of your, is on top of your fraction. You can identify H, that's this number here. Remember, it is trying to trick you. And K, there is not one here because K is being added or subtracted after your fraction. Why would I go ahead and do this? Remember, this is your, that your horizontal asymptote is at H and your vertical asymptote is at K. So that's a good reason to actually identify them so that you know where to place your vertical asymptote. And remember, you're simply using this tool right here and where to place your horizontal asymptote, which is this tool right here. Okay, then you would simply go into your calculator and you would graph the function using the 2 points in each of the branches, however they look. Don't forget to use this tool to help you graph and the plot point feature. Okay, I'm just not going to go ahead and graph that for you, but it's a branch here and here, or it's going to be a branch there and there. I can show you in Desmos, I suppose. Let me see, -2 divided by, there we go, -2 divided by x minus 1, -2 divided by x minus 1. There we go. So there it is. There is my function. I could come in and grab right there. I've got two pretty good points right here, 3. I think I'd use those 2 for that branch. I've got a point down here. And then it looks like I would probably just come over to my pad and I would add another point for myself. So there's the 4 points that I would go ahead and plot. There they are. Okay. So let me go back to our graph. I have a branch here and I have a branch here that I would go ahead and plot. And of course, remember this one connects them together. All right, our final graph is this one right here. Now, you could just use your calculator to help you graph this, but in the last lesson, we learned that this is your P and this is your Q. And the reason that we want to identify P and Q is because they're going to go ahead and they're going to help us with find our isotopes. So I'm going to go ahead and I'm going to say, right, there we go. Perfect. I want to go ahead and I want to find their degree, right? So I want to know what the degree is. I'm just going to go ahead and put a capital D. Well, the degree, remember, is the highest exponent. For me, that would be 1, and the degree here would be 1. I also want to come in and find the leading coefficients since my degrees are equal. My leading coefficient for this one is the 2 in the front, and my leading coefficient for this one is -1. So my y equals is going to be at p divided by q, which is at -2. So my horizontal, sorry, I got to keep it straight in my head, acetope is right here. There we go. And then to find my vertical acetope, I'm going to take Q, my denominator, Q of X, and I'm going to set it equal to, no, yeah, let me do that. I'm going to take my Q and I'm going to set it equal to 0, and I'm going to go ahead and solve. I'm going to go ahead and solve. So I'm simply going to solve this equation. Yes, I would show my work for this one because there is that invisible -1 there that I do have to take care of because it is now at -3. So it's going to be at x equals -3. And then once again, I can go over to Desmos or into my graphing calculator and I can figure out where my branches are. I'm going to guess they're here and here, but could they be there? Oh, wait, could they be here and here? Yes, they could. All right. Good luck, you guys. You've got this.